Welcome back. We are winding down OSCON 2017 here in Austin, Texas. Right now with me I have Kelsey Hightower, who is OSCON chair, staff developer advocate on the Google Cloud platform, right? And a ninja of the world of Kubernetes, right?
That's right.
Yeah, good deal. So I know Kubernetes was announced in 2014, right? And we're about to approach 2 years, almost 2 years. But you can't go into an open source conference without hearing Kubernetes, without seeing the logo. So, so what's responsible for the huge adoption, the huge expansion of Kubernetes in just these last 2 years?
I think it solves problems, right? Mm-hmm. Anything that solves people's problems. So containers had a big explosion, I would say 2.5 years prior. Mm-hmm. A lot of people are adopting containers, which is a kind of a format to package your application, self-contained, all of its dependencies. Mm-hmm. And a lot of people get an experience with that. And then when it's time to go to production, you're looking for tools to really manage those containers effectively. Mm-hmm. So deploying an application is just not about putting bits on disk. You also need things like service discovery, metrics, monitoring, recovery when things crash. Mm-hmm. So all of those things are what Kubernetes is wrapped up in, right? Mm-hmm. So it provides all of those features, so it complements the container world. Okay. So it's just kind of an evolution of features and problem solving that you would see for people that adopt containers as a way of packaging and deploying applications.
Okay, all right. So when it comes to deploying applications, I don't know if you can go back this far, but is it possible for you to maybe pull up from the history books what an application deployment may have looked like prior to containers and Kubernetes, and what we're looking for here also is the level of effort maybe it took before and how much easier it is today.
Yeah, so I think there's various periods of time. I can imagine a world in the very beginning where everyone is statically compiling their binaries. You can imagine writing everything in assembly or machine code, mm-hmm. and then you're producing a static artifact. Well, that's pretty easy. You take that one binary mm-hmm. and you copy it to a server, mm-hmm. or maybe you're launching it on some mainframe or something like this. Yeah. And then as time goes on, we start to get like dynamic programming languages where the runtime and the source code are separate, and maybe they're interpreted at runtime. So now you have dependency management for the first time. Mm-hmm. And in that world, we try to solve that problem with like RPM or Debian packages, where you do like yum install Apache, mm-hmm. and then that will bring in libc, some other libraries, and that was fine as long as you're on a single system and you only wanted one version of Apache running at the same time. Mm-hmm. You can imagine a world where you want two versions of Apache running at the same time, mm-hmm. but this version wants a different version of libc than this version. Mm-hmm. Now you're into this weird dependency management space. Mm-hmm. There are tools like Chroot that solve this problem, where you can actually have some isolation in terms of your file system path, where the libraries are coming from, mm-hmm. and that allows you to isolate things. But that was pretty manual. There was no consistency around it, no consistent packaging formats. Mm-hmm. Multiply that by the number of languages, Ruby, Python, Java, Node.js, Golang, mm-hmm. and now you start to get into a crazy world. Mm-hmm. Fast forward a little bit today, the cloud era, most people were just saying, hey, let's take an app and run one of them on a virtual machine. Mm-hmm. So one app, one virtual machine, and if you need more, you just scale them horizontally. Mm-hmm. But the problem with that, there's tons of waste. You're packing in different, multiple operating systems, versions of SSH, and you don't need all of that for an app. Mm-hmm. So the natural evolution is to say, hey, let's take that same root file system that we would put on a virtual machine, mm-hmm. and package it all together in a container image, mm-hmm. and then we can run multiple of those container images on a single machine. Mm-hmm. Very similar to how we do a virtual machine and a hypervisor, except for in this world, we just share a single kernel. And now we have some standards around what it means to package up an application. So a little bit more fancy than a tarball, but it gives people some consistency. So instead of thinking about every language and how you manage dependencies, we can kind of have one standard where put everything you need in the box, and then you can ship it to any of these target platforms.
Nice. And so, that would explain, like I say, the huge growth over the last couple of years is just, I guess the amount of headache, the amount of maintenance, and that sort of thing takes a lot of the weight off the off the shoulders. Yeah. So you work with Google, and I read about GKE. So that's the Google Kubernetes engine, right? So and that's part of Google's open source, free and available cloud base. Is that right?
Yeah, so Google Cloud Platform itself.
Yeah.
So most cloud providers, we sell CPU cycles, right, to sum it up. Mm-hmm. Right, we have all this compute advanced networking, global presence, all of that. But then how do you interact with those compute resources? Well, we do have VMs, which would be Google Compute Engine. That's going to be your standard, give me a VM and an operating system, and you can use your tools of choice to kind of deploy your apps and manage it that way. And then there's this open source project, Kubernetes, that we talked about earlier, and then to give a fully managed version of that, we have GKE, which is Google Container Engine. And the goal with that is to be based on open source Kubernetes, but deeply integrated into Google Cloud. So in Kubernetes, not only can you deploy your application, you can also say, hey Kubernetes, I also like a load balancer that will balance traffic between my application. So when you make that request, let's say on-prem, it'll use whatever you have there, but in Google Cloud, when you make that declaration, then it will create a Google Cloud load balancer for you, give it a public IP address, and then make sure that when you come in through the load balancer, that it round robins between all of your containers. So you can think of that for storage, networking, security, all of that's just integrated. And the way Kubernetes works is that can be done for any other cloud provider as well.
Okay, yeah, great. What would you say is, maybe some places where people are implementing Kubernetes for their applications currently? Is it more for mobile? Is it sort of spread all throughout, like enterprise mobile and everything, or?
Well, I guess once people get to the point where you're running your application across more than a handful of machines, a lot of the features and benefits of Kubernetes become apparent, and in some cases necessary. So some people have chosen to adopt a microservice architecture, right? So they want to break up their application in small pieces where it makes sense. And once you start to have that level of complexity, you're really going to want a platform that manages, easy deployment, something that's repeatable, service discovery built in, so all those little pieces can connect to each other and talk to each other. And then when you start to have multiple data centers, you're definitely going to want a consistent API to deploy to each of those data centers. So Kubernetes also provides value in that context. I have Amazon, Google Cloud, and Azure. And if I'm running Kubernetes in all three of them, I can use the same kind of tooling and APIs to deploy my applications and abstract away some of the things like storage and volumes, networking and load balancers. So a lot of people find a lot of value in that. So I think it has broad adoption and broad appeal because of that kind of flexibility, that level of integration, and also the freedom. So when you talk about Kubernetes, you also think about, well, that sounds a lot like a platform as a service, like Heroku, Cloud Foundry, and I think of Kubernetes as a step below that to give people a little bit more control. There's still a lot of opinions, but there are less of them.
Right, and then I was reading about Minikube. So is that what is that desktop installation of Kubernetes, or?
Yeah, so Minikube is so Kubernetes scales up. Supports like 5,000 nodes. You're kind of doing that kind of thing.
Yeah.
But then it also scales down. You can run Minikube as a single stack, one machine, even on your laptop. So we all have these laptops, multiple cores, lots of gigs of RAM and storage. So what we do with Minikube is we just take a single machine, and Minikube itself is a project that automates the idea of running a single node Kubernetes cluster on your machine. The benefit of doing that, of course, is that you get to reuse the spare capacity on your machine, and it's the exact same API you would use for one node or 5,000 nodes, because of the way Kubernetes works. So a lot of people like that for a development workflow. You're in operation and you want to build new tools for Kubernetes. You can actually try those tools out, and if they work on Minikube, chances are super high that they'll work on even the largest Kubernetes cluster.
Nice. So someone who's just breaking in, basically, it'd be a great way for them to become acquainted with Kubernetes. And obviously, incredibly helpful and solving a lot of problems. And I know that, I actually don't know anyone who knows more about Kubernetes than yourself. And saying that, we want our audience also to be able to find out where can they subscribe to your knowledge. Is it GitHub? Is it Twitter? Like, what are some good ways that we can reach out and keep tabs on what sort of developments that you're involved in and education that you have to offer about Kubernetes?
Yeah, so there's a couple sources. There's Udacity course that I have. So if you search for Udacity and Kubernetes, I paired with one of my teammates at Google, Carter Morgan, and we took a workshop and we turned it into a Udacity course. So it's self-paced, you step through it in little micro chunks of information. There's also a book that I'm working on with the original founders of Kubernetes, Joe Beda and Brendan Burns. Brendan Burns works at Microsoft. Joe Beda is running a founder of a startup called Heptio. So I'm at Google. So all three of us are finishing up a book called Kubernetes Up and Running, which just kind of gives you an overview. So my background is coming from like configuration management into Kubernetes. Those two worked at Google for quite a while, so they understand how systems like this work at scale. And all of those views and viewpoints are inside of the book itself. And my GitHub project, I'm just throwing everything I can on GitHub.
Okay.
So how to build a Kubernetes cluster from scratch. I have a guide called Kubernetes the Hard Way. So you'll find it there. And there's also smaller projects, like how to do configuration management inside of a Kubernetes cluster.
Okay.
So GitHub, Udacity course, there's a book, and then on Twitter. Twitter's like my global chat client. I typically keep my DMs wide open. I invite people to ask questions, show me their problems. A lot of times I can point them to something on GitHub, or even point them to work of others. There's lots of people in the Kubernetes community solving problems, and I'm happy to redirect people as well.
Nice, nice. So again, Kelsey Hightower, thank you for taking time to talk to us. And there was a lot of information there at the end. I'm going to put all of those links in the description, and it's definitely worth your time to take a look, download Minikube, play around with it a little bit, check out the book, check out the Twitter feed, check out the GitHub, all of that. Again, Kelsey, thanks for coming, and we'll see you soon.
Awesome. Thanks for having me.
All right.